So you've performed arithmetic operations with polynomials. You can also use addition, subtraction, multiplication, and division with functions, and you can perform the arithmetic operations according to the following rules. So the notation that you're going to use for the addition, subtraction, multiplication, and division of polynomials is just like it says over here on definitions. If it says f plus g of x, that just means you're going to take the two functions and add them together. So you would add f of x to g of x. If it says f minus g in parentheses and then outside it has an x, that means you're going to subtract the two functions together. F with the little dot g of x, that means that you're going to multiply the two functions together. And then f over g as a fraction of x means you're going to divide the two functions together, but whatever's in the denominator cannot equal 0. We've got examples for each one of those and how addition and subtraction, multiplication and division can differ from each other. So the first example says to add or subtract given f of x equals x squared minus 4 and g of x equals 2x plus 1, find each function. So f plus g of x means that you would take the f of x function up here and you would add it to the g of x function right here. So that would be x squared minus 4, that's the f of x function, and you would add to that the g of x function with just 2x plus 1. And since we're adding polynomials together, we are only adding like terms. This is not a distributive property question. That's what you do for multiplication. With addition or subtraction, it's combining like terms. There is no like term with the x squared, so I'll just bring it down. There is no like term with the 2x, so I'll just bring that down as well. But there is a like term with negative 4 and the positive 1. So I am going to add those together. And negative 4 plus 1 equals negative 3. So the answer of f plus g of x is x squared plus 2x minus 3. No need to factor that because we are trying to simplify, and factoring is finding the individual pieces of it, but just leaving in the polynomial form. F minus g of x is very similar to that. For f minus g of x, we're going to take the f function, which again is x squared minus 4. But we will subtract from that the g function, which is 2x plus 1. We're going to subtract the algebra way, and subtracting the algebra way is change the minus to a plus and then change the sign of all the terms in the next set of parentheses. So that would make that a negative 2x, and now that makes that a minus 1. And then we combine like terms. So again, no like terms with x squared. No like terms with what is now negative 2x after changing the sign. But I do have negative 4 plus negative 1, and negative 4 plus negative 1 is negative 5. So f minus g of x is x squared minus 2x minus 5. Let's do a couple of others. We're going to do new functions this time. So this time we have f of x equals x squared plus 5x minus 2, and g of x equals 3x minus 2. So to find f plus g of x, I'm going to add together x squared plus 5x minus 2, that's my f of x function, plus 3x minus 2 is my g of x function. We are again combining like terms, so no like terms again with x squared, but we do have 5x plus 3x, and that adds up to 8x. And we have negative 2 plus negative 2, and that adds up to negative 4. And that's that answer simplified. For f minus g of x, we're going to subtract the functions, so that'll be x squared plus 5x minus 2 minus 3x minus 2. Let's go ahead and subtract the algebra way by changing the minus to a plus and then changing the signs of all the problems in the next set of parentheses, and combine our like terms. So we would have x squared, because again there's no other like terms with x squared in this case, but we have 5x plus negative 3x, and that is positive 2x. And then negative 2 plus 2 is 0. There's no reason to put a plus 0 in there, so I'll just call it x squared plus 2x. If you put plus 0 in there, it would be okay, but it's not necessary, so you don't need to write it down. For multiplication and division, we are going to multiply the two problems together, and then also notice that the directions say that indicate any restrictions to the domain. The restrictions to the domain in this section is that you cannot divide by 0, because dividing by 0 is not legal. It's impossible to do. So what we have to do is, on the division problems, we need to figure out what values of x would make the denominator equal to 0, and that will be the restriction to the domain. So f times g of x means we are going to take x squared plus 7x plus 12 and multiply that to 3x minus 4. Since we are multiplying, this is going to be distributive property. So I have to take x squared times the 3x minus 4. I've got to take 7x times 3x minus 4 and 12 times 3x minus 4 and combine all the like terms. So when I take x squared times 3x minus 4, I get 3x to the third power. X squared times negative 4 is negative 4x squared. And then I got to take 7x times 3x, and that is 21x squared. 7x times negative 4 is negative 28x. And also have to take 12 times 3x, and that is 36x. And 12 times negative 4 is negative 48. Then we got lots and lots of like terms here. We don't have any like terms with x cubed, so I'll just bring that down. But negative 4x squared and positive 21x squared, they're like terms. So when I add those together, I get 17x squared. Negative 28x and positive 36x, they're like terms. So when I add those together, I get plus 8x. And then minus 48. So there's your answer on that one. To do f divided by g of x, f function is x squared plus 7x plus 12. And the g function is 3x minus 4. And later on, we will learn how to simplify a fraction like that. It's called a rational expression, but we're not there yet. So actually, that's going to be the answer for the division problem. But remember, we also have to indicate any restrictions to the domain, and we cannot divide by 0. So what I have to do is I have to take the denominator and the denominator only, and I got to figure out what values of x would make that equal to 0. Because it can equal 0. Any value of x that makes this problem equal to 0 is not possible, because that means the denominator would be 0, and we can't have a denominator of 0. So I'm going to set it not equal to 0, and you just solve it like if it was a regular equation. So I would add 4 to both sides. So 3x cannot equal 4, then divide by 3. So x cannot equal 4 thirds. And so that is the restriction to the domain. X cannot equal 4 thirds. I've got one more here. I just called it part C. This time it's g divided by f, not f divided by g. So since it's g divided by f, that means that the g function, the 3x minus 4, goes on the top, and the f function, which is x squared plus 7x plus 12, will go on the denominator. So when I find the restriction to the domain on this one, I need to set this denominator equal to 0, which is x squared plus 7x plus 12. That part cannot equal 0 since it's now in the denominator. So how do we solve this problem when it's got an x squared in it? Well, you can either factor it or use quadratic formula. This one is factorable, so that's what I'm going to do. So I split up x squared as x and x. And factors of 12 that add up to 7 are 4 and 3. So then I set each one of those parentheses not equal to 0, and I solve those. And so there's actually going to be 2 restrictions to the domain on this one. So x cannot equal negative 4, and when you subtract 3 from both sides, x cannot equal negative 3. So both of these are restrictions to the domain. Although this is the answer to the division portion of it, but this part 2 of this is the bottom are the restrictions to the domain. So let's do one more, and this is a complete set of problems here. This directions are we're going to find f plus g, f minus g, f times g, and f divided by g, and indicate restrictions to the domain. Remember, we only have to worry about that when dealing with the division portion. So f plus g of x would be 3x plus 4, 3x squared minus 4 plus x squared minus 8x plus 4. And I do have like terms of 3x squared and x squared, so when I add those together, I'm going to get 4x squared. There are no like terms with the negative 8x, so I'll just bring that over. And then I have negative 4 plus 4, and negative 4 plus 4 is 0, so I don't need to write down a plus 0, so this is the answer for f plus g. F minus g of x, so I'll change my minus to a plus, change the sign of all these terms. And that gives me 3x squared plus negative x squared, so that is 2x squared. No like term with the 8x, so I'll just bring it over. And now I have negative 4 plus negative 4, and negative 4 plus negative 4 is negative 8. So f minus g is this answer. For f times g of x, so since I am multiplication, I'm going to do this by distributive property. So I'll take 3x squared times x squared, and that is 3x to the 4th. 3x squared times negative 8x, and that is negative 24x to the 3rd. 3x squared times 4 is positive 12x squared. And then in the denominator, I'll have negative 4 times, excuse me, not denominator, I'll just have negative 4 times x squared, which is negative 4x squared. Negative 4 times negative 8x is positive 32x, and negative 4 times positive 4 is negative 16. My only like terms here are the 12x squared and the negative 4x squared. Everything else doesn't have a term that's like it. So I'll just bring down the 3x to the 4th minus 24x cubed, but I do combine those like terms that I have underlined, and that will be positive 8x squared plus 32x minus 16. And then finally, the division portion of it. So that will be f divided by g of x. So that's the answer, but then we do have to find the restrictions to the domain. So I will set the denominator, again, not equal to 0. And I can try to factor this if I want, but you're not going to get very far because there are no factors of 4 that add up to negative 8. It's not possible, so that means we do have to use the quadratic formula. So A is going to be 1, B is negative 8, and C equals 4. So again, using the quadratic formula, that will be negative B, so in other words, negative negative 8, plus or minus that same b squared, so negative 8 squared, minus 4 times a, and a is 1, times c, and c is 4, all over 2 times a, and 2 again, times a is 1. Negative negative 8, that's positive 8, plus or minus the square root of negative 8 squared is 64. Negative 4 times 1 times 4 is negative 16 all over 2. And that gives me 8 plus or minus the square root of 48 over 2. Square root of 48 can be simplified. Largest perfect square that goes into 48 is 16. It goes in there 3 times. Square root of 16 is 4. So I replace the square root of 48 with 4 square root of 3 over 2, and then finish it up by dividing. So I get 4, I'm dividing everything by 2, 4 plus or minus 2 square root of 3 over 1, which is just 4 plus or minus 2 square root of 3. So that is the restriction to the domain. So remember, that means that x cannot equal 4 plus or minus 2 square root of 3.